Hi friends, in this video we are going to discuss about IBM MQ point-to-point architecture with live example. Let's see what is point-to-point MQ architecture mean. Point-to-point MQ architecture is the simplest form of transferring messages from one queue manager to another queue manager through channels. The key rule we must remember is the queue manager name must be unique and transaction queue, which is a special type of local queue. Only local queue can hold the messages. The sender channel name and receiver channel name must be same. These are the important points we need to keep in mind. Now let's walk through into the architecture. Now refer with this image. We transfer messages from queue manager 1 to queue manager 2. See, this is queue manager 1 and this is queue manager 2. The queue manager 1, which is sender side, which contains remote queue, XMITQ and sender channel. These are all the components inside remote queue manager 1. Under remote queue manager 1, we have remote queue, XMITQ and sender channel. Inside remote queue, we have remote queue manager, remote queue name and XMITQ name. See, under remote queue, we have parameters such as remote queue manager, remote queue name and XMITQ. Same as under XMITQ, we have parameters like initiation queue, process, trigger data. Now let's see queue manager 2, which is a receiver side. You can see here in this diagram. In queue manager 2, it has local queue and receiver channel. These namings are used for live example. We will discuss after seeing at the end. We will discuss about it. Now let's see how this architecture works. The application puts messages. The application puts messages into queue manager. Remote queue, which is defined in queue manager 1. The message is transferred to XMIT queue from remote queue where the message is stored. Here first the application team will put the messages in remote queue under queue manager 1. From here the messages will be passed to XMIT queue. Yeah, as we know, XMIT queue is a transmission queue which is a special queue which holds messages. In XMIT queue, which is a transmission queue, we have initiation queue, process and trigger data. As we discussed earlier, XMIT queue holds a message until a trigger is append. Message header, which has remote properties. Message descriptor, which contains real messages. These highlighted ones are very important points we need to remember. Once the message header comes to the initiation queue, trigger starts, and the message will be transferred to local queue, which is defined in queue manager 2 through channels. After the trigger starts, the message is transferred to sender channel, which contains the receiver IP address. Through the network, the message gets transferred to the local queue from receiver channel. Here, as we know, the local queue defined in queue manager queue manager 2 holds the messages. From here, the application team will get the messages through batch jobs or transaction. Now let's see live examples with comments. In QManager 1, which is a sender side, as we discussed earlier, it contains remote queue, which is a destination queue properties, XMITQ, and sender channel. Here, remote queue is named as mq.remote. Remote queue manager is named as QMGR2. Remote queue name is named as mq.local. XMITQ is named as mq.transmit. Initiation queue is named as mq.initq. Process which is not mandatory, so I left it. Trigger data is also not mandatory. For example, I have used it. In trigger data, I have named as mq.trig. In under queue manager 2, local queue, I have named as mq.local. Now let's see live examples with commands. Now we are creating remote queue. We need to create remote queue first. For that, command is define queue remote which means remote queue, and we need to give the name for remote queue. RQM name which means remote queue manager name. R name means remote queue name. XMITQ, as we know, it's a XMITQ. Once we define this remote queue, now we are displaying a remote queue what we have created. The command is display queue remote and the name of the remote queue, which is mq.remote. Now we are going to create XMITQ. For this, the command is define queue local. Queue local means local queue, and the name of it usage XMITQ init queue mq.initq. Trigger data is trigDATA. Why we are using usage in init queue? Because we are specifying the local queue, because we need only XMITQ, not the local queue. So we are specifying it by putting usage command as XMITQ. Now we are displaying XMITQ like as we displayed remote queue. The same follows. Display QL. QL means local queue. The name of the local queue. Now we are going to define sender channel. Define channel, sender channel name, connection name. For reference, I have given this, but based on your project, the IP address and ports will differ. CHL type, which means channel type, which is SDR, and XMITQ, we need to put XMITQ name. Now we are going to display sender channel, which is display channel name, which is sender channel name. On MQ, on Queue Manager 2, which is a receiver side. Now we need to create a local queue and a receiver channel. Define channel name, and the channel type is receiver. Now we are going to display the receiver channel. Display channel name. Now we are creating local queue. Define queue local, which means local queue, and the local queue name. Here we didn't use usage. Why we need to use usage is while creating a XMITQ, we need to tell it is a XMITQ. So we are using usage of XMITQ. Please make a note of it. Now we are displaying the local queue, which is the command is display queue local mq.local. I hope you understand this concept. If you have any doubts, please watch from the first. Please refer this diagram, which will be very helpful. Hope you understand well. If you face any issue or if you have any doubt, please comment below. I will help you out. Thank you guys. Bye bye.